Hello students, let us continue with the disk scheduling in this particular video lecture. Let me directly go for the example. Here in this point, I'm illustrating the scheduling algorithm where a request queue is ranging between 0 to 199. So what is the meaning of that we'll see now. To look into the meaning of this queue and this particular example given here, I'll just go back to the scheduling basics. There are many sources of disk I/O requests, like by the OS, by the system process, by the user process. I/O request is first sent to the OS. Either it may be input mode or output mode, that is you'd like to read it or write on a particular location of the disk. For that you need to specify the disk address, memory address and number of sectors you'd like to transfer. OS is maintaining a queue of such requests per disk or per device. Idle disk can immediately work an I/O request. Busy disk, if already there are certain requests for that particular device or disk, then we call it as a busy disk. It is maintaining a queue. Optimization algorithms we are supposed to use so that when there is a queue is existing, in what order those requests in the queue has to be processed, that is decided by the disk scheduling algorithm. So now we'll go for the example here. So this is one such queue where the request queue is ranging between the numbers 0 to 199, and that is to access the tracks or sectors between 0 to 199. So here is the content of one such request queue: 98, 183, 37, 122, 14, 124, 65 and 67. Right now your head pointer is at 53rd sector. So what is the best or optimal algorithm in order to process all these requests in the queue, that we are going to see here. I will see the algorithms one by one. The very first one is first come first serve, that we call as FCFS in short. This I will illustrate with an example here. So let us take the same example here. The request queue is having illustration shows the total request queue is having these requests: 98 request for movement of 98th sector, 183, 37, 122, 114, 124, 65 and 67. Currently head is pointing at 53. So as you can guess, we have already seen FCFS algorithm for CPU scheduling also, wherein the concept of working of it is it works on the strategy of handling the requests on the basis of the sequence in which they have arrived. You are giving higher priority to those which have arrived first. So you have a request of 98 first, then you have a request of 183, then 37, then 122, then 114, 124, 65 and then 67. So but currently your head is at 53. So how to calculate the total head movements and average head movements, that we'll see now here. So this is you know that it is total possible sectors in the queue are between 0 to 199. So we'll just put a scale here, line here, which is having a scale line between 0 to 199. So first on the top, where is your head is pointing at 53rd sector, just make it with a mark bullet here. Then the first request in the queue is 98, right? So it is from 53, the head is moving to the first sector in the queue request, that is to the 98. So from 53 it is moving to 98. From 98 the next request is 183. So from 98 the head is moving to 183rd sector. From there it is moving back to 37th sector. So this is 37. Then it is moving back to 122. Then it is again, after that we have 14. So moving back to 14. 14 to it's going to 124, so it's going to 124, then back to 65, and from 65 to 67. The way to draw this chart is just draw lowest number, that is in the previous example it is given the request queue is having the values between 0 to 199. So your scale should have the values between 0 to 199, and just mark all these values on the scale in the order here, right? So we have 14 is marked here approximately, the scale should be taken. 37 is marked, 53 is marked, 65, 53, why 53? Because head is initially at this particular point. Then you have to mark 65, 67 because these are there in the queue. Then you have marked 98, 122, 124. We have shown only the sectors which are requested in this particular queue. So just mark all of them. Then just start with the beginning. Head pointing is beginning here, its head is initially at this point, and then the way the requests have arrived, it is moving. So how to calculate total head movements and average head movements, that we'll see here. Here it is said that total head movement is 640 cylinders. How it is 640 cylinders? So currently it is at 53. In order to move to 98, it has to, how do you calculate the head movements in order to move from this cylinder to this cylinder? That is 98 minus 53. Then from here it has moved to 183rd cylinder. So 183 minus 98 is the number of head movements. And from 183 it has moved to 37. So 183 minus 37 you are supposed to do. From 37 it has moved to 122. 122 minus 37. So how do you calculate the total number of head movements is 98 minus 53 plus 183 minus 98 plus 183 minus 37 plus 122 minus 37 plus 122 minus 14 plus 124 minus 14 plus 124 minus 65 plus 67 minus 65. So when you do all this, you'll get the total head moments as 640. In some of the problems, it is also asked to calculate the average head moments. So how to calculate the average head moments is, you have calculated the total head moments and number of requests in the queue are how many? 1, 2, 3, 4, 5, 6, 7, 8. So number of elements in the queue are 8. So what you are supposed to do is this total head movements divided by 8 you are supposed to do. In this particular example, average head movement is 640 divided by 8, that is 80 cylinders. So this is how we are supposed to calculate the way the FCFS algorithm works for the disk scheduling, and finally how to calculate the total head moments and average head moments. Based on this, we can compare the performance the different scheduling algorithm. We'll see the next algorithm in the next video lecture. Thank you.